Done.
Hi everyone, good afternoon. This is Shubham this side with my team members Bhavesh, Pratyush and Kaniksha. So we are group number 13. We have from IIT Jodhpur. We are here to demonstrate the project of our capstone project from CV department, that is Bharat Plate. This is a multi-approach system for Indian vehicles number plate detection. Our system tackles challenges unique to India, different sizes, plates, bike, car, regular fonts, whereas environmental noises like blur, shadow, and dirt. Let me begin with the system overview. Let's move through the detection mode. I would ask Bhavesh to share the screen. Bhavesh, I feel like the screen is stuck. Can you? Uh,
No,
yeah.
no.
So if we
I hope it
can,
is visible.
yeah, yes, it is visible now. So let me start. This is the landing page that we have developed. Now we have to give the username and password. Bhavesh, if you can go ahead and provide username and password.
Done.
Yes, now we are landing it. As of now, we have targeted around 5 models that we are targeting. As of in that, I have developed the YOLO 8 model. That is in this YOLO 8, and also YOLO 8 is as one of the primary detection engine that we have trained over 600 annotation Indian plates. I would like Bhavesh to give a demo for YOLO plates. So as you can see, we are randomly uploading any image. Once we upload the image, it will get processed, it will get uploaded, and post that you can see in the result section, it is with 0.80 of accuracy we were able to detect it. This model simply returns, like you can see, the confidence scores, whereas under daylight and frontal angles, whereas it performance slightly degrades when there is little night images. Also, um, we can now I would ask Bhavesh to go ahead and do the other traditional approach, that is traditional CV. Bhavesh, over to you.
Thank you, Shubham. I am Bhavesh and I worked on the rule-based traditional detection method using Canny edge detection and contour filtering. This approach is lightweight and does not require training. It works well when the plate is well lit and has some contrast. However, it is highly sensitive to shadows, motion blur, and cluttered backgrounds. So basically, I'm jumping to demo. So we are selecting the image for our model. Once image is selected, it basically detects the Indian color plate, vehicle plate. As you can see, how the edges are detected and filtered to localize a plate-like region. So now, Pratyush will walk through the color segmentation method. Over to Pratyush.
Oh yeah. So thanks, Bhavesh. I'm Pratyush. I developed the color segmentation mode, which filters out potential plates based on their color, mainly white or yellow, using the HSV masking. So it was tuned using around 300 labeled samples. While this approach is fast, it struggles with inconsistent lighting, sunlight or dirt cover plates. So Bhavesh, if you can just show the HSV mode.
Sure. So
Yeah.
we have just
So
uploaded the image and
hmm,
it has done its working. The
yes. So
HSV
here
filter
the
isolates
HSV
the
plate.
yellow region
Yeah.
and purposes it as plate as candidate. So now over to Kanishka for edge detection.
Thank you, Pratyush. So, yeah. So I worked on developing a model tuned for bike number plates, which are typically smaller and more distorted. And we used canny edge detection followed by morphological operations like dilation and erosion. This helps isolate horizontal rectangular shapes and noisy images. And can you show the demo once?
Sure.
So, as we see here, yeah. So as we see here, the pre-processing cleans up the image and the contours help focus on the plate area. And now we'll talk about our CNN classifier, which was collaborative team effort.
So I'm handling this. So to validate and classify detected reasons, we built a custom CNN binary classifier, which is trained on 1000 plus labeled patches, which is balanced between plate and non-plate images. The CNN architecture has three convolution layers, trained using Keras with image data generator for strong augmentation, rotation blur, shift, etc. So our best model is saved as CNN plate classifier best H5. It significantly reduces false positive from traditional saving modes. Just showing you a demo of CNN classifier. So first, whenever we jump to new model, we have to select our new image for further processing. I'm jumping to CNN classifier. So like we have just selected the image and it works wonderfully. So this is like findings that it had come for like for counter debug. It identified all the characters with number plate. Beautiful. So now I'm handing over to Pratyush for OCR plate recognition. Pratyush, can you please
Yeah.
come through?
So initially, we experimented with this Tesseract OCR for test recognition, but we found that it performed poorly on Indian fonts and stylized characters or even in noisy conditions. So we used it only for benchmarking purposes and then we excluded it from the final pipeline. So instead, we are currently working on a CNN-based character level recognizer as a replacement.
If Bhavesh,
Yeah,
you can give a demo. Yes.
Yeah.
our
So like we jump to demo. So we have selected an image of this number and it beautifully fetch the detail. Jumping to Kanishka for further details.
yeah. So our project is neatly modularized, models and hold trained weights, and SRC contains processing pipelines and core logic. Then assets includes test images, videos, and results. We use SQLite for data logging, and the app runs on Streamlit, hosted via AWS Windows Server, and each detection mode is encapsulated in its own capable method, making it easy to update or scale the images.
Yeah, coming back to the final conclusion and the challenges that we have faced so far. So, first of all, thank you. This was a wonderful project that we have worked on, but going through with the less time and consent, we faced very several challenges that were like the data sets that we trained our models was around close to 500 only. Once we were trying to do the training models, it took around more than 3 to 4 days to just generate the PT files and the H5 files that we are currently using for detecting the models. Also, in some cases, you might have seen that the models were not doing great, since the reason being is because of the data set trained on a less ground. If there were many other things like character detection of the Indian number plates. They have different numbers, like let's say Hindi, Bengali, other different things. So those data sets also came in picture there. Also, there were some more things is like angles. Like there were data sets that we generally use to train our straight data sets, whereas there are different scenarios where different angle templates can come in picture, but we weren't able to handle that. So as a future enhancement, we are trying to go up with that and scale up our more enhancement. Also, we are trying to deploy our project on a larger scale so that we can train our model and it can be up in no time. So that's all from our side, and this was a great learning experience. So thank you, sir. So that was a great opportunity for us. Yeah, thank you. That's all.
Thank you.